Welcome back. In this video, we are going to apply our learnings from our analysis in order to fix the main IDs that have merged users. To recap, we performed an analysis on the ID graph and one of its underlying tables in order to get an overall look at the health of our ID graph. Overall, it looked good, but we did a drill-down analysis on one of the main IDs that we know had multiple users within, and we found the specific ID value that was linked between the two users. Going back to one of the earlier videos, where we defined the entity and the ID types associated to that entity, you can remember that we defined ID types that are meant to be unique per user. In most cases, a user ID would indeed be unique. But in this case, it looks like the user ID was derived by taking the first letter of the user's first name and concatenating it to their last name. This resulted in the same user ID value for both users, and as a result, they were merged. Now the question is, now what? How do we decouple these users from the same main ID and ultimately output two separate main IDs that accurately represent the two users' graphs? In reality, the way these user IDs are derived is not robust enough, and so the most appropriate thing to do would be to fix the source data, updating the user ID values, as well as building a more robust data validation step into the user onboarding flow where they create a user ID. However, for the sake of this video series, I will walk through the various steps we can implement in order to update the profiles configuration to keep these users from being merged. Within the PB project YAML file, there is the entity definition with the ID types. Beneath that, you will notice a root key called ID types. Beneath this key is where you can define filters for each ID type. These will be converted to SQL filters that are applied within the ID Stitcher model. You will want to consider the trade-off and the implications for filtering. If you choose to filter out specific values, these will no longer end up in your final ID graph. That means they also can't be used to join the ID graph back to the source tables for feature computation, which can result in null feature values. However, this is really only a risk if that ID value belongs to a source table that is both used for feature computation and it only has one identifier column defined within the input definition. It is very common and best practice for source tables to have more than one ID column so that the join can be more robust. If a specific value is no longer available for the join can still be completed using the other ID values within a user's ID graph. There are two types of filters, include and exclude. And for each filter type, there are three methods of filtering. First, you can filter for single values. This is useful if there is a specific known ID value that you would want to filter out of the ID graph. For example, if you had a test email account used for testing user flows on your website. If you didn't want that in the final ID graph, you could filter that out. Another method of filtering is to apply a regex pattern. This way, instead of having to paste in each value, you could input the regex pattern and any email with that regex pattern will not be involved in the stitching process. The last method for filtering is using an SQL model. This is helpful if you wanted a way to exclude a large list of bad nodes from the stitching process. Note that the SQL model has to exist in the first place in order to reference it for filtering. For this use case, we want to exclude dPerez from the stitching process, so I will add that as an exclude filter type and simply filter for that value. We did not run the analysis on any of the other main IDs, but I know that the second highest offender also had two users within a single main ID. I will add that filter as well so you can see how to add multiple filters. Let's save our updated configuration and then run our ID graph again. We will then query the output in order to see the updated results. Remember from our analysis that we observed a total of 479 main IDs within our graph. If these users are decoupled from each other, we will have a lesser number of total ID values ingested for the stitching process, but have a greater number of main IDs. If all goes well, we should expect to see 481 distinct main IDs, an increase of 2 main IDs from our first run. The run is now complete. Let's get a total count of main IDs from our graph. You can see our total count is now 481 main IDs. Let's now get the count of other IDs per main ID and sort by that count in descending order to see if we have any high counts. We no longer have any counts over 35. Let's now take a look at a subset of the ID graph that consists of David Perez's email. It looks like we solved our overstitching problem. Knowing Secure Solutions' business context, the remaining counts that we see here look correct. Now that we have a healthy ID graph, we can now get to the real fun. In the next video, we will cover how to create attributes, also called features, on our user entity.